Okay, so today I'm gonna start solving this problem, design a number container system. Let me read that as I have not done it before. Okay, so let me think. Let me have the example. So find first number containers, and it has null. Okay. The next gonna be find 10. Gonna be -1. Change to 10. What does it mean? Change to 10. Index number. Okay. Index 2 number 10. And then change index 1 number number 10, and then again change, so index gonna be 3 10 5 10, and then I need to find 10, and it's what it is. Return the smallest index for the given number of this in the system. Return the smallest index for the given number in the system. Find smallest index. So for the 10, gonna be a 1. Yep, for the 10, it's gonna be 1, and then I change index 1 to 1 becomes 20. So the smallest index for the number of 10 gonna be then next 2. Okay, so what I wanna do is for every value I wanna have a, might be overkill, but like priority queue. But if I'm gonna change it, I need to somehow evict that value from the priority queue. So we're thinking about min priority queue for the indexes, and then it's gonna be the value, and the key gonna be, so the key was index value, and the value gonna be priority queue PQ for the indexes. But the problem with this approach is that if I want to replace, let's say, I need to first find a value in a priority queue at index, and then I need to evict it, and then I need to insert it to whatever new value I have. Like in this case, I evict like 1 from the priority queue for the 10, so 10 value, and here it was like 1 2 3 5, and I need to evict 1 pretty fast. First of all, I need to figure out, and it might be like, so find is pretty fast, so I need to just go to the hash map, and then go find get the priority queue for the value, and pick the top element out of priority queue, and it's gonna be the index, so the smallest index. But the problem with change, so So we need also to have a change, and this change should be in more like an efficient way. So I'm thinking right now if I'm gonna have this reversed index for the reversed index for the key to value. And if I have reversed index, I can figure out like what the value gonna be for the current. But again, so I need to find one. So it's gonna be index. No. So find has a number. Smallest index, okay. So let's say here gonna be number. Okay, I don't need to, so like, so if I wanna change number for the index, I need to figure out like which is the current number for the index, and then I need to evict that index out of this priority queue fast, and then I need to push it to the new priority queue. So the eviction procedure is kind of under question here, because like evicting element from priority queue might be too much. So it's like it's O of n, and if we have like n ops, then gonna be n squared, and that's not acceptable here. So there must be some other solution. So priority queue and index and number. So eviction is kind of problematic here, but what can I do what can I do if I can do something else here? Can I do something else? Change and find. So we have like number and it has index, like under index. So index, and then under that we have like number. I wonder like design a number container a system that can do the following. Insert or replace a number at a given index in the system. What if I just don't bother removing that value from a priority queue? If I pop the element from a priority queue, let's say if I pop the element from a priority queue, let's say we have like the values there that are kind of outdated. So if I change so I assume I'm gonna have like I can have a duplicated numbers. And then somehow whenever I do pop, when I need to do a find, I need somehow figure out that it's kind of outdated. So let's assume I have number, and then I have like PQ of indexes. And let's assume we have another hash map that has index to number mapping, and every time when I do a pop of pick from pick from a priority queue, I check if like this index is corresponding to the number from this hash map, and when it's not match, I just evict that element and then do another pick. So I do pop and then pick. So that's gonna be it. So short summary, let me check the time. Short summary, I wanna have like a data structure and I wanna have a duplicates for the numbers. No, for the indexes, yeah. And they might be like no match in the priority queue, and wanna have like first data structure gonna use is a hash map, and the hash map, and it's gonna hold the number as a key, and the value is gonna be integer, and the value is gonna be priority queue, and it has like gonna have like indexes inside, and I'm gonna order the priority queue by so the lowest element, the lowest index gonna become first, and the second second data structure gonna be hash map with a mapping between index and a number. And what I'm gonna do in case I need to change, I will just update this hash map. So I put the new for the given index, I'll add or update the number, and I also will check a hash map here and put the number, put the index in the priority queue that matches this number. And for the find operation, so the putting number in so the updating hash map gonna be O of 1 complexity, and the putting a value into priority queue, it's gonna be like log n, O of log n. And so the total time complexity for the put gonna be O log n. And then for the find operation, I'm gonna first find the mapping between index and number. I'm gonna I need a mapping between number and number and index, number and index here, index. And then I'm gonna find the mapping between number and index, and then I'm gonna try to pick the index here from the priority queue, and if this index is not mapping, I will pop the element from priority queue, and I'll try to do next pick for this number. Oh no, like, shall I have like index number? Let me index. No, yeah, I shall do index number, because I can have like at given index I can only have one number. So like I should evict index and number from hash map. That's a problem. So for the find given number, check the index, and then for this index I check if it's the key, if it's the valid number. So there is one mapping between index and number, so 1 to 1. So like one index might have one number, but there might be like many numbers under. There might be like one number and the different indexes, so it's like one to many relationship. No, like many to one, kind of. So hash map for index number will be fine. So I'll try. So right now we'll have hash map with integer and then priority queue integer, and then it's gonna be pick number to PQ equals new hash map, and then I'm gonna have hash map integer, and it's gonna be number to let's remove this one underscores to make it precise, like shorter. Number to, so index to number, and it's gonna be also a new hash map. And then I'm gonna, for the change, let's say, yeah, for the change, let's start with the change. So for the change, I wanna do the following. I wanna index to number. So yeah, so index to number, I wanna put index and number, and then for the priority queue number to PQ, I wanna put and then for the number I wanna get or default, and then number to PQ get a default. Get, I wanna have under the number new priority queue, and then gonna be integer. If it's just comparator, integer compare, and then I will I'll go priority queue integer equals get a default like this, like here, and then I'll wanna so that's gonna be PQ, and then I wanna PQ.offer index, and then I wanna put this PQ back, or like put it like a new one into this number to priority queue hash map. And then for the find function, what I wanna do is like while, let's say boolean try equals false, while try equals, let's say 2, say while PQ is not so I want to first get the priority queue for the integer PQ equals number to PQ dot get for the number, and then if PQ is equal null, then return -1. Otherwise, while PQ not empty, and in the end I wanna return -1 if I don't find anything good there. So I wanna have PQ dot pick index. Let's see, index equals PQ pick, and then I wanna check if index to number get index is equal number, then I wanna return index. Otherwise I wanna PQ dot pick poll. Yeah, something like that. So this is this solution is built on the fact that I wanna like store duplicates duplicates for the index for the number to indexes pairs, and then I wanna like keep track of the valid pairs in the hash map, and then whenever I pick in find, I check if it's a valid pair. If it's not valid pair, I just pull the element from the priority queue. If it's a valid, I return the index. So that's gonna be it. It doesn't allow me to do this one. Let's do integer by 1, integer by 2, then I'm gonna return integer compare e1 e2. Zlata, be quiet, please.
I'll show you. Hey, no, it's laptop, please. I just want to see it around my neck. I'll do it around.
Okay, priority queue.
Hey, it's attached. It should be attached to you. Let me see for yours. So attach it. I need to attach it, bro.
Okay. So here. Too many brackets, I guess. Priority queue. Get a default. Okay. The same priority queue. Okay, let's run it. Okay. Let's check editorial. What they have? 2 maps using heap with lazy update. Okay, I was using heap with lazy update probably. Like 2 maps. Okay, for the 2 maps I wanna have 3 set. Oh, but this one is. So it's better for find. Let me check. 3 set for the index to numbers. Okay, there's I have index to numbers. The number to indexes is a 3 set. So the 3 set is gonna be balanced maps from number to set of indexes and from index to number. Okay. Change. Okay, let me check what the time now. Okay, the time is like 30 minutes. I will call it pass. I didn't have any kind of flows in a solution. But yeah, could have been like faster, but I saw this for the first time, so that's it.